Alright, so the next part we're going to talk about a few algorithms. We're going to start with a simple greedy algorithm, and we're going to introduce two. So the first one is defined in the following way. Now let's first define what it means to be greedy. So when we talk about greedy, what it means is that we are basically maximizing a short-term gain. So in this case, we are going to build the solution by taking one step at a time, and in each step we are going to optimize for just the next one step. So for example, right, just in real life, right, you're hungry, so if you're being greedy, you're going to eat a lot, right? So that's going to optimize for that moment, but in the long run, it may not be the best thing to do. So in the same way, in a greedy algorithm, most of the time we try to simplify the problem just by looking at one step at a time. Now, let's take a look at an example, right? So let's first show the following distance matrix. So in this case, you are given 5 cities, and the distances in kilometers are given in the matrix. So as mentioned earlier, there is only half of the matrix because the distances are symmetric. Then when we execute a greedy algorithm, what we are going to do is to construct a tour. Now, what do we want at the end? We want a round-trip tour that visits every city once. So one way to do that is to start somewhere. Now, where do we start? So in this case, we're going to start from a random point. So if we follow the pseudocode that is given on the slide, it says that the first step is to be a tour of one city that is picked randomly. So in this case, so one city picked randomly. So we're going to go to this matrix, we're going to pick one city at random. And let's suppose at the moment that the city that we pick randomly is Belfast. So that is going to be the starting point. So at first, you only have one city. The next one, we are going to pick the next city. And since we are now at Belfast, we are going to pick the one that is closest to B. And based on these distances, the closest to B is Dublin. So we go from Belfast to Dublin. Now, we don't care about what goes on after Dublin. We just choose based on the next one step, and that is going from B to D. Now, once we're at D, then we can continue the greedy process by picking the next city that is going to be closest from D. And the closest from D, other than Belfast, is Limerick, which is 198. So then we just continue. And from Limerick, the closest one, okay, now we have two choices, either to Cork, 105, or to Galway, 105. So if there are two equally good options, we break the tie at random. So we're going to pick one of them. So let's assume we're going to pick Cork. So in that case, we just continue. And then from Cork, well, in theory, we should pick the next closest city. But by now, all the cities are already visited except one. And that one is Galway. So we have no other options but to pick Galway. So in this case, then, once Galway is picked, so because it's a round-trip tour, then the whole tour is going to go that way. Now, this is a greedy algorithm. So there are some principles behind this. So the first principle is that we only optimize for the next one step. And we always start from where we left off, right? So at first we get B, we add D, we add L, C, and G, and so on. Now, once you arrive at a solution, like this is one trip, this is one solution, this solution is not actually one solution. This is actually 10 solutions. So why is it 10 solutions? Because your trip here is a circle. So you don't actually have to start from B. You can pick any starting point. You can start from B, or you can start from D, or from L, from C, from G, right? So there are 5 possible starting points. And wherever you start from, because it's a round-trip tour and the distances are symmetric, you can either go clockwise or anti-clockwise. So that means that just from this one tour, you can actually execute 10 different tours. So which means that the solution that you get, although we started with B at the beginning, it doesn't actually mean that in real life, when you're going to execute a tour, you have to start from B, just because the algorithm starts from B. What it's basically saying is that the tours are equivalent as long as you just do circular shift and in clockwise or anti-clockwise direction. All right? So So keep in mind, okay? So just because the algorithm started from B, it doesn't mean that once you arrive at a tour, you have to start from B, because it's a circle anyway, so you can start from any point. Now, this is one way to be greedy, which is to take the simple step each time, one step at a time, right? So in that sense, we can execute this pretty quickly, and we're going to arrive at a specific solution given the starting point, and the starting point here is B. And you can actually start from different starting points. Now, this is one way to do greedy. In this slides, we are going to introduce a second way to be greedy. And by the way, greedy 1, which is what we just did earlier, there is an implementation inside the graph lab. Now, there is a second greedy solution. Now, the second greedy solution is a little bit more complicated, because the whole point is to actually expand the space of options that we are considering. So remember earlier, in the first greedy algorithm, we just go from one city to the next city. From A to B, B to C, C to D, and so on. In that case, we are actually being very myopic, right? So we are only caring about how to go from one stop to the next. But in theory, you can actually expand the trip in many different ways. You don't have to expand the trip only from the last point. You can expand the trip from any earlier point. And that is essentially the principle that we get from the second greedy algorithm. I'm going to describe this using an example. So here, the first difference is that the starting point. And the starting point is not random. In fact, we are going to start from an initial tour of 2 cities with the closest distance. So we are not going to start at random. Instead, we are going to start from the closest 2 cities. So that means that the hope is that by expanding that, we are going to get a better solution in the end. Now, and then we're going to expand the tour 1 city at a time. And the way we do that is to choose the one with the lower overall distance among the cities. Okay, so let me give you an example. Okay, so now this is greedy 2. So the starting point is the pair with the smallest distance. So in this case, you actually have 2 options. You either get the Limerick and Cork at 105, or Limerick and Galway at 105. So since there is a tie, we're going to break it at random. And let's say in this case, let's pick the first one, which is LC. Now, which means that at first, you already have a small little tour. And the small little tour is going to take a distance from L to C, 105, then C back to L, 105. This is just the starting point. Now we want to expand this tour by 1 city. Now, how do we expand the tour? So earlier, when we talked about greedy 1, it's going to take the last point and then expand it, right? But now we're going to be a little bit more careful. Instead of just expanding from the last point, we're going to try to expand from every single point. Since L and C are both already in the tour, so then we ask the question, if I'm going to expand from L, where should I go next? And if we look at L, since C is already in the tour, the second option will be to go to G, right? So if I'm going to expand from L, I'm going to go to G because the distance is the shortest at 105. Well, that is one option. Another option is to expand from C. So I can expand from C. Now, if I were to expand from C, where should I go next? Well, from C, if you look at the distances, other than L, which is already in the tour, the smallest distance is actually G, 209, right? So that means I have 2 options to expand. Either I expand from L to go to G, or I expand from C to go to G. Now, it doesn't matter here whether they are the same or they are different. We are just going to look at what is the smallest distance. And the smallest distance here is 105. So I'm going to pick this option. Now, what does it mean to pick this option? It means that I'm going to expand the tour from L to G, which means I'm going to add G into the tour. Now, I'm going to add G into the tour. Where can G go? Now, G specifically must be next to L because we are expanding from L, right? But for G to be next to L, it could mean that G is before L, in which case I'm going to get a GLC, or I'm going to put G after L, in which case I'm going to get an LGC. So I have two tours. Either I expand to the left or I expand to the right. Now that I have two tours, I can compare them. Which one is actually shorter in terms of the distance? Well, it turns out that for three cities, the tours are actually identical because the distances are symmetric. Because I have the GL here, it's the same distance as LG. I have the LC here, the same distance as LC. There's a GC here, which is the same distance as GC. So effectively, the two tours are identical. So I don't need to worry about which one I pick because they are the same tour. So I'm going to pick one and then expand. And let's assume that I'm going to pick this one. Now let's say I will pick this one. Now I have three cities already in the tour. And we want to expand, right? We can expand from any city that is already inside. Okay, so let's say if I go and expand from G, where can I go? So there are only two cities that are not yet in the tour, which are D and B. So from G to B is 306. From G to D is 219. So G to D is smaller, which is 219. Now, if I start from L, which is also in the tour, where do I go? So both C and G are already in. So the closest distance is to D, 198. And if I start from C, where do I go? So C here. So now that I consider all of them, okay, so between B, 425, and D, 257, D is smaller. So we pick D, 257. Now, which means that we have got three options to do expansion. Either we expand from C by adding D, or we expand from L by adding D, or G by adding D. And we look at the smallest distance, which is this one. So now we know we are going to expand by adding D next to L. Now, what does it mean to be next to L? It could be before L or after L. That means now I'm going to look at the possibility of GDLC or GLDC. So I have two options by placing D next to L, because D could come on the left or D could come on the right. So then I'm comparing these two options to see which one is smaller. This one is the same. The GC is the same. So then I'm comparing GD here, 219. LC, which is 105, in this case DC 257, and GL, which is 105. So 105 is the same, the difference is 219 and 257, right? So this one is smaller, this one I'm going to drop it. So by now I have got a tour of 4 cities, which I'm going to expand one more time into the next one. Now, but there are 4 cities already in the tour, so there is only one city that is outside. Which city is that? Is B, right? So we know that the only possible expansion now is to add B into the tour. But how do I add B into the tour? I have to figure out which one to expand. So B itself is closest to D. So then I know that I need to put B next to D. But to put B next to D could mean that B comes on the left of D, or it could mean that B is on the right of D. So then we are comparing GB, D, L, C, or G, D, B, L, C. Now some of the distances are the same. Right, so then we are comparing GB, which is 306, DL, which is 198, and GD, is 219, and BL, which is 323. So here, clearly this is smaller than this is smaller than this. So I'm going to accept this, I'm going to reject this one. So then the final tour is going to be this one. Now again, we have got one final tour, but it's not actually one solution, it's actually 10 solutions. Because you can start at any starting point, and you can do it clockwise or anti-clockwise. They are all going to be different tours that make use of the same distances, and therefore they're going to have a same overall distance. Okay. Now between greedy 1 and greedy 2, there is a difference. Now first, the key principle. The key principle is that initially we have no solution. So we're going to construct it one at a time by adding one city at a time into the solution. Now the difference is essentially a trade-off between speed and how many solutions do you want to actually examine. So in the greedy one, we are going to make it very fast. Every time we expand from the last visited point, just to go into the next city, next city, next city, next city. In the greedy 2, we are a little bit more careful in the sense that, firstly, when we expand, we don't just expand from the end, we are going to examine all the possible points to expand. The second, even when we decide where to expand from, we need to examine whether we want to put it on the left, put it on the right, and compare the two cases. Alright? Now, this one I think will need a little bit of practice. So I think what we'll do now is to do some exercise. Now, my first suggestion is that you try to redo the greedy 1 and greedy 2 for exactly the same distance matrix that we had earlier. And once you are done, you can then try out a different example where we are going to use a different matrix here. Okay, so try the greedy 1, try the greedy 2, and then in about 15 minutes time, you're going to discuss together.